In various science classes, oftentimes we have very large or very small numbers to work with, and it is often easier to write them using scientific notation. For example, if we have the number 230 million, we want to go ahead and write that using scientific notation. We start with a number between 1 and 10, and looking at those numbers, 2.3 is indeed a number between 1 and 10, and we're going to write 2.3 times 10 to some power. We want to find out what that power is, and we do that essentially by counting decimal places. So what we're going to do is we're going to start on the right, and we're going to count how many decimal places we have to go to get that number between 1 and 10. 1, 2, 3, 4, 5, 6, 7, 8. So that would be 2.3 times 10 to the 8th power for that number. Let's do another one. 3, 4, 0, 0, 0. Followed by many more zeros. And again, the number between 1 and 10 would be 3.4. Times 10 to some power. So we're going to go ahead and count to see how many that is going to give us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 3.4 times 10 to the 13th. For very, very small numbers, the exponent will be negative. So if I have 0.00000000743, we're going to express a number between 1 and 10 to start with, and that number will be 7.43. And in this case, the number is very small, so it's times 10 to a negative exponent. So let's see what that'll be. We'll do our counting. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be 7.43 times 10 to the negative 9th power. And we'll do one more. A whole bunch of zeros, and then 8, 2. So we start with a number between 1 and 10, and that will be 8.2 times 10 to some power. And we'll count to see how many those are going to be. 10 to a negative power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times 10 to the negative 15. And if you want to go from scientific notation to standard notation, that's not very difficult. If I have 6.31 times 10 to the 7th, well, we write 6.31. Put in a whole bunch of zeros. We're multiplying by 10 to the 7th, so every time you move the decimal place to the right, you're multiplying by 10. Times 10 to the 1st, 10 to the 2nd, 10 to the 3rd, 10 to the 4th, 10 to the 5th, 10 to the 6th, 10 to the 7th. It would land there. So what's that? That's 631, followed by how many zeros? 1, 2, 3, 4, 5. And in the case of a problem that has a negative exponent, if I have 4.73 times 10 to the negative 4, we write 4.73, and this time we write zeros to the left. I need a whole bunch of zeros here. And if we're going times 10 to the negative 4, we are dividing by 10, and that requires us to move the decimal place to the left. 1, 2, 3, 4. So that gives us 0.3 zeros. 1, 2, 3, then 473. And certainly we can add and subtract numbers expressed in scientific notation. So if I have 4.2 times 10 to the 8th plus 7.9 times 10 to the 8th. You'll notice they're both times 10 to the 8th. So what I can do here is I can factor out the 10 to the 8th. And I can say 4.2 plus 7.9 times 10 to the 8th. 2 and 9 is 11, carry a 1. 7 and 4 is 11, plus 1 is 12. So I have 12.1 times 10 to the 8th, but I want you to notice that is not scientific notation. We'd have to go ahead and recognize the fact that the number here is not between 1 and 10. The original number must be between 1 and 10 to have it in scientific notation. So what we'll do is we'll rewrite this in standard form first. 1, 2, 3, 4, 5, 6, 7, 8. So that's 1, 2, 1, followed by how many zeros? 1, 2, 3, 4, 5, 6, 7. And then we can rewrite that in scientific notation by taking 1.21 times 10 to the 9th. And in terms of multiplication, if I have 3.2 times 10 to the 5th times 6.3 times 10 to the 4th, what we would do here is we would multiply 3.2 times 6.3 then we would multiply 10.5 times 10 to the 4th, excuse me, 10 to the 5th times 10 to the 4th. 10 to the 5th times 10 to the 4th we know would be times 10 to the 9th. Then we need to do 3.2 times 6.3. So we realize we have two decimal places, 1, 2, so we ignore those and we take 32 times 63. 3 times 2 is 6. 3 times 3 is 9. 6 times 2 is 12. 6 times 3 is 18 and 1 is 19. 6, 11, carry 1, 19 and 1 is 20. With two decimal places, that gives us 20.16. So we have 20.16 times 10 to the 9th. Now this is not scientific notation because the first number must be between 1 and 10. So let's rewrite that, expanding it out. A whole bunch of zeros. Move the decimal place 9 places to the right because we're multiplying by 10 to the 9th. Each time we move it to the right, we're multiplying it by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. It now becomes 2016, followed by how many zeros? 1, 2, 3, 4, 5, 6, 7, followed by 7 zeros. So that will give us a number between 1 and 10, 2.016, times 10 to some power. And let's count them and see how many that will be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2.016 times 10 to the 10th.